Hello everyone. So today's chapter is matrices or we can say linear algebra, and the topic is rank. So basically the definition of rank states us that if we are having a matrix A of order m cross of n and R be the rank of the matrix A, if and only if there exists a square submatrix B of order R such that its determinant is non-zero and determinant of every submatrix of order R plus 1, that is higher order, must be 0, and it is always denoted by rho of A. This is the symbol rho of A. Okay, but in simple words I'll let you know what is the definition for this one. We can say that the number of non-zero rows in a matrix is known as the rank of the matrix. Okay, this is the simplest definition which you can remember it. And it is denoted by rho of A. So rank of A is always less than the minimum of row and column. Okay, for example, if I have a square matrix, so rank of A is always less than, let us suppose the matrix is of order 3 by 3. Okay, so rank of A will be minimum of 3 and 3. That is what rank of is either equal to 3 or less than 3. But if I am taking a matrix that is a rectangular matrix 3 by 4. So in that case rank of A will be minimum of 3, 4. Now 3 rows 4 columns, so minimum is 3. So that means we don't consider the value 4. So the rank will be either equal to 3 or less than 3. Similarly, if I am having a matrix of 2 by 4, so rank of A will be less than equal to minimum of 2 and 4. Now from 2 and 4, which is minimum? 2. That means rank will be less than or equal to 2. We will not going to consider about 4 or 3. Okay, it will be either 2 or it will be less than 2. But minimum rank of any matrix is always 1. Okay. So now when we are going to find the rank of a matrix, so there are two methods. So one method is known as minor method, and the second one is known as operation method or elementary transformation method. Okay, these are the two methods. So we will be discussing both methods one by one. So starting with the minor method. So let us suppose we have been provided a matrix capital A is equal to 4, 2, 3, 8, 5, 2, 12, minus 4 and 5. So this is a matrix and its order is 3 by 3 right down there. So one thing is clear that rank of this matrix A is less than equal to 3. Okay. Now what I need to find the determinant of the given matrix first of all in minor method. Okay. So determinant of A is equal to 4, 2, 3, 8, 5, 2, 12, minus 4 and 5. So when I need to find the determinant of it will be 4 into, now I need to leave this row and this column, so it will be 5, 2, minus 4 and 5, then negative 2, then determinant I need to remove this row and this column, so it will be 8, 2, 12 and 5, and the last number is 3, this 3, determinant. Now this row and this column to be leave out, 8, 5, 12 and minus 4, determinant. Now I need to operate this one, 4 into 5 5s are 25 minus 4 2s are 8 with a negative sign, so it will be plus 8 minus of 2, 8 into 5 40 negative from our side, 12 to the 24 plus 3, 8 into 4 minus 4 32, minus from our side 12 5 the 60. Okay, now it comes out to be 4. Now it will be 33 minus of 2, 40 minus 24, that will be 16 plus 3, so minus of 92. So 4 into 33, 4 3 is a 12, 2 1 carry, 4 3 12 1 13, minus 16 to the 32, then minus 92 3 is a 3 to the 6, 9 3 is a 27. Now 132 minus of 3200 minus of 276, so it comes out to be minus 176, which is not equal to 0. Therefore we have to leave this question over here and we say that rank of A is equal to 3. Okay, that is the result. Now let us suppose the given matrix of order 3 by 3 is equal to 0. In that case, what I need to find all the minors of A of order 2 by 2. Okay, and then we need to take all the determinants of that minor part to, we need to find out all the values, and if at least one of that minor is non-zero, so we can say that rank of A is 2. Okay, let us take one more example from minor method. So now the question is, we have a matrix A, 2 3 13 3 6 12 2 4 and 8. Now again it is of order 3 by 3. Okay, so first thing which I know that rank of A is less than equal to 3. I need to find determinant of A, that will be 2 3 13 3 6 12, then 2 4 and 8 determinant. So number 2, so I need to leave this row and this column, 6 12 4 and 8. Now next number 3. Now since we know that this is taken to be positive, this to be negative, and this is to be positive, so minus 3. Now leave this row and this column, so it will be 3 2 12 and 8, and then we have plus 13 and this row and this column, so it will be 3 2 12 and 8 determinant. Sorry, 6 and 8. Three, 2, $13, then it is 3 6 2 and 4 determinant. Okay, now if I solve it 2 times, so 6 into 8, 8 6 are 48, minus from my side 12 4 are 48, minus 3, 3 8 are 24, negative from my side, 12 2 are 24, plus 13, so 3 4 are 12, minus 2 6 are 12, so I got 2 into 0, minus 3 into 0, plus 13 into 0, that counts to be 0. This means rank of A is not equal to 3 and is less than it. Okay, so I'll leave it as, now rank of A is either less than or equal to 2. Now I need to take all the minors of this matrix A. So starting with the first row, first column, I leave 2. Okay, because since we know that we have already done 3 cases, leaving 2, leaving 3 and leaving 13, all the values are 0. So that means the minor of 2 will be 0, minor of 3 and minor of 13, all the 3 minors will be 0. Now I am moving towards the number 3 from this part. So what will be the first value? 3, if I leave 3, so it will be 3, 13, 4 and 8. So minor second row first column, that will be 3, 3, 4 and 8. So if I solve it, so it will be 3 8s are 24, 4 3s are 12, which is equal to 12 and is not equal to 0. So we have received at least one of the element whose minor is non-zero. Okay, so that means we have to leave it over here. That means rank of A is equal to 2. Let us suppose minor of this value is also 0. So we need to calculate the minor of the next number, 6, similarly 12, and we have to stop at that value whose minor is non-zero. Okay, and we have to proceed so on till we are getting the value 0. Hope it is clear. So taking one more question from this one. Now we are taking a matrix which is of rectangular form. So matrix is 1, 2, minus 3, minus 1, 3, minus 4, 1, 2, then 5, 2, 1 and 3. Now we know that we have 3 rows and 4 columns, so order of this matrix is 3 by 4. Okay, and by definition we know that rank of A is always less than or equal to minimum of 3, 4. That means its rank will be less than equal to 3. Now I don't need to find the determinant of A. I need to solve the values of order 3 by 3 only. Okay, let us take the first matrix or determinant, that is 1, 2, minus 3, 3, minus 4, 1, 5, 2 and 1. So determinant of it one will be 1. Now this row and column to be leave out, minus 4, 1, 2, 1, then minus of 2, I need to leave this row and this column, 3, 5, 1, 1, then minus of 3 again, row and column to be leave out, 3, minus 4, 5 and 2. So value will be 1. 4 into minus 4 into 1, that will be minus 4, minus from my side 2 into 1, 2, minus of 2, 3 ones are 3, minus from my side 5 ones are 5, minus 3, 3 twos are 6, minus from my side 5 fours are 20, with the negative, positive 20. Okay, so it reduces to 1 into minus of 6, minus of 2, 3 into minus of 2, minus 3 and 26. So it will be minus 6 plus 4 minus 26 3s are 6 3s are 18, 3 to 6 and 1 78. So minus 78 plus 4, that is minus 74, and then will be minus of 80, which is not equal to 0. So that means I have to leave it over here itself. So rank of A is equal to 3. Okay, let us suppose this value comes out to be 0. So I need to find all other matrices or determinants of order 3 by 3 from this whole matrix A. Okay, and if all the minors of this matrix of order 3 by 3 comes out to be 0, then I need to take minus of order 2 by 2. That is the basic concept of this matrix. Okay, so hence we can sum up this question or this method in minor method. What we have to do, we have to find the determinants of the matrix, and if it is not equal to 0, the order of this determinant will be the rank of this matrix. And if this determinant reduces to 0, so we need to find the determinants of order 1 less than it. If it is of order 3 by 3, so we need to find minors of order 2 by 2. And if one of them is non-zero, so the rank of this matrix will be 2 in that case. Okay, I hope everything is clear to everyone. So in this video we have completed the topic of rank by the method of minor, and in the next video we will be covering the topic of evaluating rank by using elementary transformation. Okay, thank you, have a great day.